Alright, welcome back. This is our second PowerPoint presentation in naming or in Physical Science 9 chemical reactions. This presentation is titled Naming Compounds, and if you recall, in our previous PowerPoint we described the necessity of having a universal language for chemistry for scientists all around the world. Naming compounds is important so that all scientists from around the world can understand what is being described when we talk about compounds. So again, it is essential that we have a universal system for naming the compounds, similar to our universal system for measuring. Again, we use the metric system for measuring meters, liters, grams. So we must kind of follow that lead and have a universal system for naming the compounds. Now, we have special rules for ionic and covalent compounds, which makes it necessary for us to identify which compounds are ionic and which compounds are covalent, because different rules apply for naming them. We need to follow those rules to appropriately name an ionic or covalent compound. In order to use the right procedure, we must first decide whether it is ionic or covalent. And again, how do we do this? Remember that an ionic compound is one that happens between a metal and a nonmetal, and covalent compounds are those that exist between two nonmetals. So if we look at a chemical formula and we see a symbol for a metal and one for a nonmetal, we're going to use the ionic procedure. But if all we see is nonmetal symbols for elements, then we're going to use the covalent compound procedure. Now, we have a specific procedure in the notes for doing this, and if we look at our notes, we can see and as we scroll down what our procedure is. For naming compounds, ionic compounds require us to name the metal first. We also then name the nonmetal second, but we drop the ending and add IDE. To give you some examples, we see NaCl, which stands for sodium chloride. Notice that the Na stands for sodium, the chlorine is Cl, but we drop that INE ending and we add IDE. In the next case, we have MgO. Mg stands for magnesium, O stands for oxygen, but of course we drop the ending and add IDE, so we end up with magnesium oxide. Lithium is Li and F is fluorine. Again, drop the ending and add IDE, so it's lithium fluoride. Now, there are some kind of special examples here on our notes page that describe polyatomic ions, and here we have a list of some common polyatomic ions. And when you use a polyatomic anion, do not change the ending. So here we have Na, which is sodium, and OH, as we see in our list of polyatomic ions, is a hydroxide, so sodium hydroxide. Mg is magnesium, CO3 from our list is carbonate, so magnesium carbonate, and Ba is barium, NO3 is nitrate, as we can see here again from our list of polyatomic ions. Now, if we scroll down to covalent compounds, notice that we're supposed to use prefixes to represent the numbers. If we just take a moment to go back up to ionic, it doesn't matter what our numbers say down here. We don't ever refer to those numbers because we know in ionic compounds they always must balance out to cancel the charges. Well, that's not true for covalent compounds. We don't try to balance out charges. So it is important for us to understand how many of each atom we're talking about. In order to do that, we're going to use prefixes. The prefix for mono is, or the prefix for 1 is mono, 2 is di, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, 10 deca. To give you an example of how this plays out, we're going to start with the prefix for the first element, but we never start with mono. And then we're going to name the first element. We're going to use the prefix for the second element, and then we're going to name the second element. I should have mentioned too that we're going to change the ending and add IDE. So don't forget to change the ending to IDE. An example of that is CCl4. There's only one carbon here, so that just is carbon. And then the chlorine, there's 4 of them, so we're going to use the prefix for 4. It's carbon tetrachloride. H2O, we know the common name for H2O is water, but the technical name is dihydrogen monoxide. And then CO2 is carbon dioxide. Remember, notice that we don't ever use mono to start the name of a covalent compound. Acids can be named. We simply just change hydro first, and we change the ending to IC. So HCl is hydrochloric acid, and HBr is hydrobromic acid. Okay. Now, if the acid involves a polyatomic ion, do the same as in step 1, except skip putting hydro first. So instead of putting hydrosulfuric acid, we're just going to put sulfuric acid. We skip out the hydro. This would be carbonic acid, and then HNO3 is nitric acid, and H3PO4 is phosphoric acid. There are many examples with which you can practice now, so I would suggest that you take some time to look in your notes page and practice naming those compounds.